Welcome back to my classroom, humans. Today we're tackling a particularly baffling concept in quantum mechanics, the wave function. Yes, I know. It sounds like something you'd ride on a cosmic surfboard, but trust me, it's far stranger than that. Now let me break it down for you in a way that even my litter mates would understand. Imagine this. It's dinner time, and someone, a kind, generous soul, perhaps yourself, has placed a delicious tuna sandwich on the table. Naturally, I want that tuna. But where exactly is the tuna? On the plate? In the air as a wafting scent? Or halfway to the floor after I've given it a solid paw swipe? The answer, my friends, lies not in classical mechanics, but in the wave function. The classical way of thinking is simple. Tuna has a position x at time t and a velocity v. If I know both position and velocity, I can predict where the tuna will be at any given moment, ideally in my mouth post-haste. But here's the catch. In quantum mechanics, you're no longer allowed to simply say, the tuna is here. Instead, you must describe its wave function, which essentially says, the tuna might be here, or it might be over there, or maybe it's everywhere at once. Who's to say? Now, the wave function isn't just me being indecisive about where my snack is. Oh no, it's much deeper than that. Think of it as a swirling cloud of possibilities, like a dream where the tuna might be here, there, or everywhere at once. This magical cloud tells you the chances of finding my tuna in one spot or another. But don't get too comfortable. This isn't some simple dice-rolling game like my humans play with Monopoly. No, this is quantum probability, where things are delightfully and chaotically uncertain, just the way I like it. Here's where things get fun. You see, in quantum mechanics, probability isn't about ignorance like it is when you roll a die. With dice, you just don't know all the details, how fast the die is moving, how it'll bounce, etc. But in the quantum world, even if you know everything about the tuna's state, you're still stuck saying, I don't exactly know where it is, but I know the likelihood it'll be near the plate versus on the floor. It's not a lack of knowledge. It's baked into the quantum laws of the universe. Or as I like to say, curiosity didn't just kill the cat. It made everything uncertain. So how does this look in practice? Imagine you've set up a tuna experiment with a detector. Let's call it my nose. Before you measure, the tuna exists as a wave of probabilities, a smear of maybe here, maybe there. But the moment I sniff it, bam! The wave function collapses and the tuna is either on the plate or tumbling to the floor. Spoiler, I will still eat it. Now let's wrap up with my favorite part. Quantum mystery. Why does this work? Is the tuna actually everywhere at once before I sniff it? Does my mere act of looking at the tuna make it choose where it is? These questions are why physicists lose sleep at night, and why I, Professor Max Purrwell, have claimed the title of quantum nap expert. Because sometimes, friends, the best way to deal with uncertainty is a long, satisfying nap. So the next time someone accuses you of not knowing where you left your keys, just tell them you're thinking like a quantum physicist. Now, if you'll excuse me, there's a tuna sandwich whose wave function needs collapsing. Class dismissed. Wuff sparkles.